just going to another topic, okay, which is it's completely related to data warehouse. Okay, it's completely related to data warehouse. Okay, so already we know that what is business intelligence, right? What is business intelligence? Business intelligence is something which we convert the raw data or transform the information into some meaningful format, right, to make the business decisions happen, or to make the decisions on some facts, right? So this is what is business intelligence, right? We already talked about that. This is the time we know about a concept of data warehouse. Okay, so what is data warehouse? Data warehouse is nothing but the data is actually stored in a database, right? As we were discussing in the previous classes, data warehouse is not a new tool. Data warehouse is not a technology, right? Data warehouse is a domain, is a concept, but the physical data storage is in a database. Okay, one database in your SQL Server or Oracle or DB2 can be your data warehouse. Okay, but the kind of data what we have in the data warehouse is it will be in a different format than the database. Okay, so basically data warehouse is a repository of an organization's stored data and is designed to facilitate reporting and analysis, right? So if you remember our few first classes, I already told you that database, you have to create a database for storing the data, but the kind of format you store the data in a data warehouse is a bit different than the normal database tables, right? Okay, so this data warehouse, and if you link this up to the real-time example, so what is a warehouse? Warehouse is a place where you store some things, right? It may be rice, paddy, or wheat, or it can be anything. Yeah. So in the same way, if you store the data into some place, it is called as a data warehouse. Okay, but not everything will be becoming data warehouse. Example, if I just have some employee data or some salary data, it is not a data warehouse. Data warehouse has some properties, so some few things to follow. Okay. Okay. So if you look at the screen, there are some things here. Okay. If you look at this screen, there are some things here. Data warehouse should be subject oriented. Data warehouse should be subject oriented. It means that it should talk about a subject. So what is the subject? It should talk about sales of the company. It should talk about HR department of the company. It should talk about the finance department of the company. It should talk about the logistics department of a company. It should talk about a marketing department, right? It should be related to some subject, right? It cannot be just data by itself. It should be related to some subject. Okay, change the color. Take orange. Yeah? And it should be integrated. It should be integrated, right? So what is the meaning of integrated? There are two pieces of information when you're talking integrated. It should be gathered from variety of sources, and at the same time it should be linked to different things. Example, I have few set of data for finance department, right? What I will have in the finance, I will have the list of employees. I may be having what are the expenditures by the different employees, right? So this kind of data I'll have in the finance, or I have some accounts and receivables, right? So I have an HR system where they talk about my compensation, performance management, right? But I have the list of employees also in the HR system. So I have one employee object in finance system, I have one employee object in the HR system. I cannot have two different employee objects, right? I should be having only one employee object, which should be talking to two different data marts or two different domains called finance or HR, right? So it should be integrated and connected. Yeah, and it should be time variant. Okay, so what is the meaning of time variant? Okay, so time variant is something like this. Okay, there is a salesperson in a company who is performing the sales. This year he is achieving a target of $100,000, but previous year he achieved a target of $80,000. and before that year he achieved a target of $70,000. As the time passes, the values of the targets is getting changed based on his performance. So data warehouse should be a place where it should not depend on a particular time. It cannot just give the data like I can give only the current year's data, I don't have the previous year's one. It cannot be like that. It should have the historical information, right? So whatever the time it would be, at that time what is the thing happened, at that time what is the thing, it should be time variant, okay? Then only we call it as a data warehouse, okay? And it should be non-volatile. What is the meaning of non-volatile? Non-volatile is something like information in the data warehouse should not be fluctuating. Information in the data warehouse should not be fluctuating. It means you cannot just delete the data. Okay, you cannot just delete the data, right? So you can have the data as a historical information. Maybe you can have the new things as a new inserts, but we never delete the data. But if you don't want some data, what we will do is we will do some flags and put saying them that okay, this information is not required, something like this, but we never delete the data, right? So data warehouse should be subject oriented, talk about a subject, finance, HR, logistics, right? It should be integrated, it should be talking to all the other departments and other things also, and it should not depend on the time. Whatever the time you are talking about a year called 2005, it should be able to give the year sales of 2005, right? It's a time variant and it should not be deleted, right? It should maintain the historical information, right? So this is if any of the database has this kind of properties, then we call it as a data warehouse. If any of the database does not have this kind of properties, we don't call it as a data warehouse. We don't call it. Yeah. So what is the advantage of a data? So now you understand the data warehouse, right? So what is a data warehouse? So data warehouse is nothing but it's a physical database, right? It's like a physical database. So in a physical database there are different tables, right? Here you have a table, you have here a table, here you have a table, right? But the kind of format you store in the table is different than the normal database. So what kind of format is we will see. Okay, but it should be integrated, non-volatile, subject-oriented, right? So this is something called as a data warehouse. Yeah. So what are the advantages of data warehouse? Data warehouse is a common place for all the data of the company, for the entire data of the company, right? Example, you talk about finance, HR, whatever it may be, it should be in a single place. That we call as a data warehouse, right? So there are some advantages, right? Like the company CEO can come and just ask, okay, so what are my sales for this year? Or some company executive can ask, what are my revenues for this particular division? Okay, or someone can ask that, can you give me the information where list of salespersons who are working both with sales department and marketing department, right? Or someone will ask like, just these are my core products for this year. Okay, so just give me like what is the performance of the different salespersons on these core products for this year. So the questions can be anything, right? So it should be able to answer. So data warehouse is one of the place for that. That's the advantage of data warehouse. Okay, so there are using data warehouse, actually we can design some concepts called cubes for reporting and analytics purpose. And data warehouse talks about single version of truth. Okay, so data warehouse always talks about single version of truth. So data warehouse is a place where we get entire information of a particular organization. So there are some advantages of data warehouse, but at the same time there are some disadvantages of a data warehouse also. Okay, so what are the disadvantages of data warehouse? Basically, data warehouse, to build a data warehouse, so there are some lot of ETL operations or backend operations happening, right? So the data is not real time. If someone says that, okay, 5 minutes back I have some transactions, can you give me summary of those transactions? No, data warehouse cannot do it. So data warehouse needs some time where the ETL process will happen, gather the data and store the data into the system. So there will be some time consuming, and that's why there is a latency. And at the same time, data warehouse is very high cost. So once a company starts a data warehouse project, they should make sure that they have a proper skill set, and they should make sure that they have the proper servers, and they should make sure that the maintenance cost is very, very high. Okay, so that's one of the disadvantages. And data warehouse is only a place for structured data. If you have some junk data coming here and there, this, that, so for those kind of things, data warehouse is not a place. Maybe you can store it somewhere else. Yeah. So these are the disadvantages of data warehouse, right? Okay, so here you will talk about the difference between a database and data warehouse. Yeah. So what is a database? Database constitutes real-time information. Yeah. As and when the transaction happens, the information is already there in the database. Right? Example: a person deducting $500 from the ATM machine can already see his in bank account as deducted. So where is it reading the data? It is reading the data from a data warehouse. But if a person is looking at the different charts and trend analysis, that information will be coming from a data warehouse. Right? So this is in the database, it's a real-time information, but in the data warehouse it's not real-time, but it's considered the entire information. Some you can have all the raw set of data for some analysis. So databases are used to run the business. Example: online banking, ATM machine, or point of sale machines in a retail outlet. Right? Any retail outlet, if you go to some Guess store, or if you go to some Super Dry store, right, or Mango store, any store, you'll give the cash, do the payment, take the receipt and go. So where the data will be storing? It will be in a database. But data warehouse is not like that, right? So data, once that information goes to database or a flat file, everything is integrated to give some analysis information, and to give some reports how the business is running, and to give some information how we can improve the business. Okay, so the real business intelligence lies in the concept of data warehousing. Right? But business intelligence consists of various parts, right? SSIS, AS and RS in Microsoft. IS is used to take all the ETL things in its hand, right, and to load it to a data warehouse. And once the data warehouse is loaded, we will use SSIS to create the cubes, right? Okay, so there is something called as data mart. So these are some of the interview topics or discussions where you might need to know about it, right? So there are some other things called as data mart. So what is a data mart? I just talked about something, right? I have a finance domain. In the finance domain, I usually talk about my customers, my employees, what are my receivables, what are my payments, and what are my sales information, say, right? Or what is my forecast? This kind of information I am talking in finance. So this set of tables can be a one data mart. If I talk about a domain called sales, what I will see is I will have the list of sales reps. I will have the list of divisions on what they are working. I'll have the list of transactions on what they have worked. I will have the list of performance management. Example: what is our sales rep quota for this year and what is his achievement, right? So this kind of information I'll be having in the sales. So each domain of this kind is called as a data mart. When everything is integrated together, that's called as a data warehouse. But data warehouse is a combination of data marts. Okay, so data mart is a departmental data warehouse that stores only relevant data. Example: finance or sales. It is a subset of an organizational data store the focus on a particular subject area that may be distributed support business. Example: sales domain, right? In short, data warehouse contains many subject areas, as in the data mart contains just one of those subject areas. Yeah, as I said, data warehouse is a combination of logistics, finance, marketing, sales, right? Anything. But data mart is only talking about one domain. It's a logical sub-entity of a data warehouse. And there is another concept called operational data store. Okay, so what is this operational data store? Okay, so operational data store is nothing but it's kind of a database. Okay, actually it's also a database often used to interim area of a data warehouse, right? So what happens is, example, if you are working in a sales company, right, like sales and distribution company, so you generate the invoices from one system and the invoices will go to the customer. So that will happen from a transactional system, right? That will happen from a transactional system, and from the transactional system, from the database, we load the data into a data warehouse, right? But we don't want everybody in the organization to connect to our data warehouse to pull the information. We will give a place for you to read the information from that place. Please don't touch our data warehouse. Example, if you are a business user from finance, you are not supposed to touch the IT system, which is a data warehouse. Please don't touch it. I will give you some other place, right? And I'll put the required data there. Just use that. That place is called as a ODS, operational data source, right? Okay, very important. The next slide. In the data warehouse, there are two big heroes who has started this concept. Okay, in this concept of data warehouse was not present before early 90s. This started only in late 90s. Okay, in early 90s there is no concept. Nobody has thought. There was some concept, but nobody has really put on paper like how actually it works. This concept is from late 90s. Right? There are two big guys like who started this topic, and if you can already see there is a Kimball group in the, if you go to the Google and search Kimball. Okay, if you go here and just try, there's a Kimball. Okay, if you type Kimball, right, so there is a Kimball group. Okay, there is a Kimball group where they talk about dimensional data and data warehousing, and this guy is a Kimball, right? His name is Ralph Kimball. So he has given major contributions, and there is a group for data warehouse and dimensional modeling discussion, all those things. So just try to go here and you'll learn so many things. Okay, very important website. Okay, so two guys, right, like they call the proposed two concepts of data warehouse. So we will see like what Inmon said is, okay, so let me take a pen, right, arrow, spotlight, choose a pen. Okay. Let me take a pen. So what Inmon was saying is, this guy says that to build a data warehouse, don't go by data marts, don't go by subject area. Whatever you want, you try to build it on a overall data warehouse level. So don't try to build on a subject area and come up with the total warehouse. So what he says is, starts with building large centralized warehouse followed by data marts. Okay, he says that don't concentrate on low level things, just start with high level and do the things, right? And he says that to have a data warehouse, no need to go for dimension tables and fact tables. You can have the normal third normal form. I think you already know the normalization, right? First normal form, second normal form, third normal. So just if you have a third normal form, then it is already okay for a data warehouse in the company. Okay, he's saying like that. He's saying that, but this is a time consuming, and he says that it is a top down model. So just build the high level centralized data and do the data marts later. Example, just whatever you want is just build a centralized data and just come down as your data mart. So don't go for dimension tables, fact tables and all those things. So we will see what are those dimension table, fact tables in the later section, right? But what he is saying is, just build a centralized data warehouse as a normal tables, like a database, and you can have that as a data warehouse also. Okay, he proposed the concept of data warehouse in that way. But what Kimball did is, Kimball came in between. He said that, okay, this is very old, whatever Inmon is saying is very old concept, but if you use this concept, then you will be into some problems. He said that don't build the data warehouse on from high level. First of all, try to start from his basic thing. Build a data mart for sales, right? Build your employee structures, build your sales data, you build your sales transactions, link them up, and make sure that it is up and running, right? Build your finance data mart, build your marketing data mart, build your logistics data mart, right? And then once everything is ready, just connect them. So his approach is actually a bottom-up approach. Okay, he says that it takes lesser time to do the things, and he talks about creating multi-dimensional model rather than the 3NF, right? So here, using this multi-dimensional model, actually we talk about a concept called cube, right? And he supports things called star schema and Snowflake schema. And always, I already told you, it's a bottom-up approach to have the data marts first and data warehouse later. So there are pros and cons of each of these sections. But usually, in my experience, okay, whenever I was working in all the BA projects, if you want to satisfy your business user with some quick output, okay, always the companies are going for Kimball approach. From my last 9 to 10 years of working knowledge on BA and data warehouse, I have always seen data warehouse with Kimball approach. This approach is seen only in few companies where they feel that the amount of service for end users needed is not needed as quickly as possible. It is okay to slow down, but just keep it on very high level. Usually these type of things, only 20% of the times this will happen, but 80% of the times this Kimball approach will be followed. So make sure that you have good knowledge about the Kimball approach. Okay, he talks about data marts, he talks about dimensional model, star schema, Snowflake schema. It's very important to learn these things. Okay, there is all drawings here. If I go to the next topic, right? So just remember that mostly in the next few classes also we will be giving the examples of the Kimball method, right? And SSAS is a tool which is developed on top of Kimball method. Okay, so you can go to this kimballgroup.com and you can learn so many things about dimensional modeling and data warehouse, right? So this is a group for business intelligence and data warehouse experts, right? So he's Ralph Kimball who is talking about this one, and there are a lot of others who is contributing this. Yeah, you can learn so many things here free of cost, right? So just try to go here and just make the information updated, right? Like, okay. So Inmon is talking about top-down approach, right? Kimball is talking about bottom-up approach. So what do you mean by top-down approach by Inmon? It is like a third normal form. It is like a normal database, right? He's talking about entity relationship model. Many tables will be used for joinings, and there will be history tables, and there will be that. It is good for indirect end user accessibility. It is not good for direct end user, right? But if you are working in an end user company, people expect to give the things as soon as possible. That will be from Kimball. Kimball group is dimensional modeling. He talks about facts and dimensions. He talks about star schema. So we'll see what is that. So he talks about denormalized structure. Very important topic. We will discuss in the next few slides. And he will talk about some surrogate keys. It is saying that he says that if the end user wants the data as quickly as possible, please use my approach. Okay. So we'll concentrate on Kimball approach. Okay. In the next few classes, where all the organizations are also following that. But if you already have the knowledge about the database, then it means that already you know the Inmon approach. Okay. Okay, so what is the architecture of a data warehouse? And as I told you, it is connected with the different source systems. You will do the ETL using SSIS, and you will store the data into a database, which is called as a data warehouse, and you will do the reporting here. the reporting can be using the OLAP, which is a concept of SSIS, and it can be from the reporting also. It can be from any direct reporting tool. Yeah. Okay. So here comes the slide, right? Here comes the concept of dimension tables and fact tables. Okay. So before going anything here, I just wanted you to know some information and guess some information out of it. This is a very important topic. If someone is very new understanding this, right, I hope you refresh these things even after the class. Okay. Okay. I'll show you something here. Let me connect to a database called VentureWorks. Select star from. Okay, I want to select from AdventureWorks dot v sales dot v salesperson. Okay, this is one of the views I have. Okay, here there are some things to be learned. Okay, there are some things to be learned in this particular thing. Okay, see the particular data set, always you will be having some information, right? But that information can be categorized, should be categorized into two forms. Okay, this is the Kimball approach. Information to be categorized into two forms. One is any information you should categorize into one form called dimensions and another form called facts. Okay, so any information please categorize into two parts. One is dimension, second is facts. Okay, so what is a fact? So what is a fact? Fact he is talking about. Fact means anything you talk about numbers is called as a fact. Okay, a particular salesperson Stephen, okay, has a sales. Okay, so let's take another record. Michael, right? So a particular person called Michael has a sales quota of 300,000, but he has achieved 4.5 million. Here I am talking about numbers, right? This is a fact. I am talking about a fact. I am talking about a number. Anything which you talk about a fact or anything which you talk about a number will be coming into the facts. So in this table, what is my fact? Anything I see with the number is a fact, right? But not all the numbers are facts. Example, invoice number. Invoice number is not a fact, right? Invoice number is just for reference. So here, if I am talking about sales amount, sales target, if I am talking about any numeric fact, right? If I am talking about some accounts receivables or account payment, right? So these type of things are called as facts. So in this table, I have some few facts, right? I have some few facts like sales quota, sales YTD and sales last year. So anything which I see as a number, mostly it is called as a fact, right? So what are my facts here? Sales quota, sales YTD, sales last year, right? These are my facts. And anything in which I am seeing this data against, in any data which I am seeing with respect to these facts is called as dimension. So I am seeing this data on the dimension of Michael, right? I am seeing this data on the dimension of Michael. So for Michael, it is they have sales quota, sales value, last sales price. Those are the facts, right? So I am seeing in the angle of Michael, I am seeing in the dimension of Michael. So whatever the dimension you look at the data is called as a dimension. So what is my dimension here? Dimension is first name, middle name, last name, all those things, right? And sometimes I may be looking at the dimension of a say job title also. Okay, so what are my sales quota and target of my sales reps? And what is my sales quota and target of a sales manager? This is sales manager, right? So this is also one of the dimensions I may be looking at. Okay, so here the sales manager will not have any quota because all his subordinates has a quota. Okay, and whatever the achievement of his subordinates will be his target, right? So I may be looking at the dimension of this one. I may be looking at the dimension of a phone number or email address, right? So whatever the angle you are looking at, okay, the angle, the way of the angle you are looking at that your data is called as dimension. Here the first name, last name, job title is called a dimension, right? So whatever the numbers you are talking about, it is called as a fact. Here what are the facts? Sales quota, sales YTD and sales last year. Okay. Okay, coming back here. So this is the concept of dimension tables and fact tables. So what you will have in the dimension tables? Dimension tables will have the data. Dimension tables will have the data of different dimensions, or dimension tables will have the data of, it will have the data in which angle you are seeing, looking at the data. Sometimes you will be looking at the data on a product angle. Sometimes you will be looking at the data on a sales rep angle, right? Sometimes you will be looking at the data on a core products angle, right? Sometimes you will be looking at the data on a time angle, like for this year what are my sales. Sometimes you will be looking at the data in a different angle, right? So it can be any angle. So these are the angles I am taking. So the angle can be a time, or it can be a location, or it can be a product, or it can be a sales rep, or it can be a core product, any angle, right? All these angles, the way you look at your numbers, okay, all these angles, the way you look at your numbers are called as dimension tables. Okay, the data what you see in the fact tables, the numbers whatever you are seeing against those dimensions will be in fact tables. Okay, very important difference. What type of data should be there in dimension and what type of data should be there in the fact. Okay, dimension will have the way you look at the data, and facts will have the facts. Okay, right? So then that actually completes the concept of dimensional modeling, right? So dimensional modeling will have dimension table and fact table, right? So I hope you understood what is a dimension table and what is a fact table, right? We will see how the structures is. Okay. Okay. So the next few slides, right? The next few slides we'll be talking about two important concepts. One is normalization, second one is denormalization. Okay. If you already have the background knowledge about a database, okay, if you already have a background knowledge about a database, you should be having the knowledge about normal forms. First normal form, second normal form, third normal form, right? So this is called as normalization. So we will talk about normalization and we will talk about denormalization. Okay. So here quickly I will show you what is normalization in a database. Okay. So there are basically every database product, if it has to follow the RDBMS rules, minimum it has to go through these normal forms, right? So there are three normal forms, right? I'll tell you what is normalization. I think people already know that, but the information is something like this. Okay. The first, so when a data set is considered as first, will contain the first normal form, basically it should not contain any duplicate values and it should have a primary key. Then it will be a first normal form, right? It should have a primary key and it should not have any repeating group of columns. Here actually what it is having is this particular customer is having two products associated to him, but actually it cannot be like this, right? It has to be splitted because the information is repeated, right? The information is repeated. Each column must have single value, so it is not a first normal form. So if I split this like this, what will happen is it is containing multiple columns of the same kind of information. Still it is a kind of duplicate, so it is not in first normal form. If I split it into the rows format, what happens? Same information is duplicated in the form of rows. This is also not first normal form. So what I have to do to make this into the first normal form, I have to make sure it is having a primary key, right? So my primary key is customer ID, and if you take the combination of this product, right, if you make this as a primary key, then I don't consider this as a repeating group of information. If I put only customer ID as primary key, then it is a repeating group. So that is the, you can consider the first normal form is completed. But there are still problems with this one, right? So we need to apply second normal form to make sure that it has a very clear structure of data. So what second normal talks about is every non-field must be having a dependency on the primary key. Okay, what I'm talking here is, example, if you take this slide, right, every non-key is having a dependency on the primary key. It's not right. Example, this particular table, this is a customer ID, customer name, customer last name. Okay, these are actually, this is the primary key. Okay, it's considered customer ID and products is the primary key, right? The combination of this is primary key. And you have customer name and last name. This is non-key, right? Okay. So what second normal form talks is every non-key field must be depend on the components of the primary key. Do you think it is dependent? Example, this first name, last name is depending on this product? No, right? This particular person can buy any other product in the future, right? Today he bought a shirt, or she may be buying some trouser in the future, or she may be buying some bag in the future, right? Actually, non-key attribute is not dependent on the primary key, which is wrong, right? So because our primary key was customer ID and products, right? So how it can satisfy the second normal form? Basically, it should be dependent on only customer ID, not the products, right? So it should be like this. These non-key columns, whatever the columns, customer first name and last name, is depend on this one, right? Is always dependent on the primary key. Non-key columns are dependent on the primary key. That's how it should be. So that's why we should create one other table with customer ID, customer first name and last name, right? This is in the actually second normal form, okay? And each customer ID can have any number of products buying from them, right? This customer may be buying a cell phone, and tomorrow he may be buying a TV or a sofa or anything, right? So those things should be separated. Then all the non-key columns will be dependent on these are the non-keys. Non-key columns will be dependent on the key column. This is second normal form. What is third normal form? Basically, it should be in both first and second. It should follow first and second normal form. What is first normal form? It should not have any repeating values, and it should have one primary key, right? And it should not have multiple same group of columns repeating everywhere in the columns, right? That's first normal form. Second normal form is all the non-key columns should be dependent on the primary key. Example, products was not depending on the customer name, last name, right? It can change, right? It's not dependent, and it can be for any other person also. So those type of things should be separated, right? First normal form, second normal have to be satisfied for third normal form, and there should not be any transitive dependency between non-key and key attributes. Okay, very important. What do you mean by transitive dependency is, example, if there is a particular product, right? This price is 500 and the tax is 50, which is a 10% of the price, right? Which is 10% of the price. So this particular product set and this is the price. These are dependent, right? And based on the price, actually tax will change. These are dependent. Okay. So what is happening here? There is no transitive dependence between non-key and key attributes, right? So what is happening? This is actually, this price is depending on this product, and this tax is depending on this one. Actually, this tax is not dependent on directly on shet, right? So it means that there is a linking. One is depending on another depending on another. It cannot be like that, right? So how it should be? It should be that this particular product is this price. That's it. Okay. And if the price is this one, the tax is this one, or just set the percentage here. So this should not be like half dependency here, half dependency. That's the normal form, right? Okay, so this is the concept of normal form. I hope like if you are working on a database, you should be already knowing that, right? So just for information, I have repeated that. So, but what you can do is like you can go through the normal forms. So that is normal form. So where Inmon says that we should be having third normal form to build a data warehouse. But what Kimball says is, no, the tables should not be in normal form. The table should be in a denormalized format. Very important interview question. Okay. Normalization is different than unnormalization. Unnormalization is different than denormalization. Okay. Normalization is different, unnormalization is different, denormalization is different. Okay. Normalization means whatever we talked just now. Unnormalization means if you don't do the normalization, that is called as unnormalization. Okay. And there is another third topic called denormalization. What is a denormalization? Denormalization is exact opposite of normalizations. It means that we will entertain duplicate values. Okay. We will have the duplicate values in dimension tables. We will have the duplicate values in fact tables. Okay. But what we will do is we will make sure that it is used for some purpose and which is available very fast to the end user, and you can do the analysis in a multi-dimensional angle, and we'll try to reduce as many joins as possible. Okay. So denormalization is a technique. Okay. Denormalization is a technique where you will create the concepts of dimension tables and fact tables. Okay. And you will store the data in some format. So in the next few slides I'll make you understand what exactly is this denormalization meaning. Okay. What exactly is this? Let me clear my drawings here. Okay. So so there are two concepts in the data modeling. One is star schema, snowflake schema. Okay. Okay. So what is for star schema, snowflake schema? This is too early for you to understand. Okay. Before you understand the concept of denormalizing. Okay. So we have the concept of dimension tables, fact tables, right? Okay. So what I'll show you is okay. I'll come back to those slides, right? I'll come back to those slides, but before that what I'll show is I'll show you how a denormalization thing works. Okay. Okay. So example, you have one employee data, right? Employee ID, first name, last name, age. Okay. You have the employee data like this, and you have department data, right? So department data is like this. Okay. So that is something related to type of schema. I'll come back to those slides. I'm trying to make you understand the concept of denormalization. How the concept of denormalization works is, you will have a concept called dimension table and fact table. Okay. You will have a concept called dimension table and fact table. So what is a dimension table? The way you look at the data, the angle at which you are looking at the data is called as a dimension. Okay. The facts you are looking in the data, or the numbers you are looking in the data, are called facts. So what are the examples of dimensions? Product dimension, location dimension, time dimension, sales dimension, core products dimension. It can be anything, right? What are the examples of facts? It means sales number, total amount, quantity, all these are called as facts, right? Example. So there is a manager, he says that how do I find sales figures in units, amount per month, per dealer? So there is an automobile business, okay, where they sell cars, okay. So there is a question, he is asking question, for this dealer, for this month, how many number of cars I have sold? For this dealer, for this month, mean how many number of cars I have sold. So what is this dealer? Dealer is a dimension, right? Because we are looking at the data on the angle of dealer. Per month, we are looking the data on the angle of month, which is time, right? So this is one, dealer is one dimension, time is another dimension, but unit is a fact, right? And these cars are nothing but products. Okay, so if you come, you will have one dimension table called dealer. Okay, because you are looking at the data on the angle of dealer. You are looking at the data on the angle of month, means which is time, right? Which is date. You will have a date dimension table, or time, and we call it as a time dimension also. Okay, and he's asking per dealer, right? So sometimes like the dealer will be having some the different branches, right? So sometimes like for this branch, for that branch, so you can have a angle of branches also, so the branch dimension. So what they will be looking at the number of units sold. Example, if you take any car company, they have so many brands in it, right? So each brand is categorized into one product. So you should have a one product dimension. So what is this question? For one dealer, it means from dealer dimension, for month, from date dimension, please give me number of units. What is unit? Unit is a number, it is a fact, right? For this dealer, for this month, important, okay? For this dealer, for this month, for this product, in this branch, what are my number of units sold? What is my revenue? These are the facts or numbers, right? These things are all called facts, and it is in the fact table. How dimension table and fact table is linked? How dimension table is fact table is linked? They are linked with a concept called surrogate key. Interview question. Okay. There is a concept called surrogate key. What is a surrogate key? Surrogate key is a key which connects the dimension table and a fact table. Example, you have a dealer ID in dealer which will be having the same dealer ID in the fact. This is called as a surrogate key. This is a surrogate key. Example, date ID in date dimension will be linked to date ID in fact table. This is called as surrogate key. Product ID in product table will be linked to product ID in fact table, right? Here it is showing as not linked, so it is, they are showing it as model ID, which is same as product ID. Yeah. Branch ID in branch table is linked to branch ID of fact table, right? 1, 2, 3, 4, 4 keys. It means for this dealer, for this month, for this product in this branch, I have, these are my facts, units sold and revenue. So what I will do here, if I have 10 dealers, if I have 12 months, if I have 5 products, if I have 2 branches, what are the number of records here? This multiplied by this, multiplied by this, multiplied by this. Means if there are 10 dealers, 12 months. For each dealer, there should be 12 months, right? 10 into 12, 120. And each dealer will be having 5 products for each month, right? 120 into 5. What is that? 600. And there are 2 branches, 1200, right? So all this combination of 1200 records, all this combination of 1200 records will be stored in this table, which is called as a fact table. I repeat, these are the different dimension tables. Different dimension tables will be linked to a fact table using a concept called surrogate key. The number of records in the fact table is the multiplication of number of records in all the dimension tables connected to it. Here it has connected to 4 different dimension tables using the different surrogate keys. If there are 10 dealers for 12 months, it means 120 records. For 5 products, it becomes 600 records, because one dealer 12 months 5 products, another dealer 12 months 5 products, so 600 records into 2 branches, 1200. So this table will be having 1200 records, right? Okay, so this 1200 records is the maximum records it will have. Why? There may be some of the dealers in a particular month, actually they don't sell in anything. 0 is the unit, so there may not be any record at that time. If they don't sell anything, there is no record. So the maximum number of records having in the fact table is the multiplication of all the dimension tables, or it can have less also. Yep. Any questions? Please raise it out. Very important topic. If you don't understand this, then there is no value in attending tomorrow's and day after next week's class. Okay. So this is called as dimension table. This is called as fact table. Okay. Here it is connected in the form of a star. This whole structure is connected in the form of a star. Okay. That's why this schema is called as a star schema. This whole structure is connected in the form of a star. You can have another table here, right? Or you can have another table here. So this whole structure is in the form of star. That's why this type of schema is called as a star schema. Okay. And there is another type of thing, another type of schema we have. Okay. Example, there may be a product, but at the same time there may be some sub-products. So what you want to do is you want to maintain a different table for products and you want to maintain a different tables for sub-products. Okay. At that time you may have to normalize this particular table, right? If you normalize any of your dimension tables, means if you split any of your dimension tables into multiple tables, that type of concept is called as a Snowflake schema. Okay, that type of concept is called as a Snowflake schema. So what I'll do is I'll go to the previous slides. So here we have two things, star schema, snowflakes. What is a star schema? A fact table contains a column of each measure as well as column for each dimension, right? Each dimension is connected to the center of the fact table, right? That's called a star schema. And if you are normalizing any of the dimension tables, it means product table is divided into sub-products, then it will become a snowflake schema. Okay. So data modeling concepts, and so this picture says that an isolated island itself cannot be very productive. It has to be linked to with another island so that there is some business and activity going on, right? If you take employee table and department table, usually we link up employee table and department table, right? So that we get the specific information, right? And we saw this example, and here we talked about the thing called dimension tables and fact tables, and this is called as a star schema because all the dimension tables are connected to a centralized fact table. But if it comes to the concept of snowflake schema, there will be normalization within the dimension tables. It means a product table can have a sub-product table here, and these two will be linked, right? Or a dealer table may be having a sub-dealer. Okay, so when you normalize your dimension tables, or when you split your dimension table into multiple tables and link it together, that concept is called as a snowflake schema. Okay, so important, in star schema dimensions are not normalized, right? So here nothing is normalized, so it's a direct pure dimension. Good query performance has lesser number of tables joined. So as there are lesser numbers, it is a very good performance. So mostly in the organizations we try to start with the star schema. We try to build the star schema, but if there is any performance problem or if there is any problem in the star schema, we'll try to normalize the dimension tables to make it more optimized. Then it becomes the snowflakes. Usually it happens on the architecture wise also. We start with star schema, but due to some problem we normalize the dimension table, which will become a snowflake schema. Yeah. So just go through this. All the concepts I explained just now is in the star schema, snowflake schema, right? So this is one of the examples of star schema, right? Dim customer, dim date, dim product, right? What is a dimension table? The way you look at the data is a dimension table, right? Dim customer means it is always talking about the customer details. It will not talk about any sale. You talk only about customer details, right? What is dim date? Dim date is something like it will talk only about the date dimension. It will talk only about the time, right? What is product? It will talk only about the product. It will not talk about anything else, right? These three are linked together to in the internet sales. So which is a fact, right? Anything you talk about a number is called a fact. Okay. So what it will do is for this combination of surrogate key, it will have the same linking here and it will have the different facts. What are the facts here? Tax amount is a fact, freight is a fact, sales amount is a fact, total product is a fact, product standard cost is a fact, discount amount is a fact, unit discount amount is a fact, extended amount is a fact, unit price is a fact, order quantity is a fact, right? So these are all the facts, right? These are the so many facts, but the other keys are linking keys to this dimension table. So this is a star schema. So what is Snowflake schema? As I told you, Snowflake schema means if this dealer is splitted into some location based on country. You have list of countries, you have some list of locations, and these locations and these countries are connected to this dealer, right? You're splitting this information from the dealer to different things, or you are having the product and you have a sub product here. You are splitting the dimension tables into multiple tables. That concept is called as a Snowflake schema, right? In Snowflake schema, dimensions are normalized. Query performance not so good as joins are more, right? Because you have to join this, right? So because you have to join too many tables, the query performance will be very slow. Yeah. So this is the concept of Snowflake schema, right? Okay. So if you see here, right, this is actually Snowflake schema. Earlier we just saw that this is one dimension, this is another dimension, this is another dimension, which are linked to this one, right? But at the same time, for every customer, this dim customer actually is linked to dim geography. So it means that this particular table is split into these two. One is customer, and customer is linked to geography, right? You may be having 100 countries in the world, right? And in each of the country you will have some maybe 100,000 customer, right? So these two are linked. So dimension table is split into two dimensions. Yeah, this customer dimension is split into country dimension and customer dimension. So that's why it will become a Snowflake schema, right? So whenever you want to do a query, right, it has to query with this one, with this one, with this one. So the number of joins will increase in the Snowflake schema. Okay, I hope you understood this, but try to do some exercise on this one. Try to read out something. So what type of schema works for you in the organization? So there is no definite way of saying. Usually organizations start with the star schema, but depending on the project input, or depending on the requirement, or depending on the data size, we will convert that into the Snowflake schema. So there is no guarantee for that, right? Okay, so you have some. So I think I have explained you a little bit of the things, right? So there is some. So what I'll do, I see there are some few questions, right? So I'll read out the questions here to make sure that you guys are in the same page. What's the time now? Okay, so we will continue the class for next 15 minutes, right? So by that time I'll try to read out some questions, right? Have some few questions like, can we say surrogate key is same as foreign key? No, surrogate key is not same as foreign key. Surrogate key is same as primary key. Okay, surrogate key will be located in the dimension table. Okay, surrogate keys are located in the dimension table, but surrogate key will be used to link to the fact table, right? So it's a primary key because it is linked. It comes to the concept of foreign key. But you can say it is almost equal to primary key, but primary key and surrogate key are not same. Okay, primary key may be okay, so physical concept wise surrogate key and primary key may be same, but data warehousing concept wise surrogate key concept to primary key concept is different. Every surrogate key has to be linked up to a fact table to make sure you get the correct results. Yeah. So you can treat the surrogate key as a primary key. Okay. But when you explain the concept of surrogate key, you should make sure that you say that it should be that surrogate key will be part of the dimension table, but that will be linked to the fact table. Then only it will be become the surrogate key, right? And some other question, that can we say that both of the model exists together in most of the data warehouse? Usually when you talk about the organizational data warehouse, right? So there will be only single data warehouse for the organization. Usually so organization should have one enterprise data warehouse. Okay. When you talk about data warehouse, one company will have only one data warehouse, which will be enterprise data warehouse. Okay. It means it will have all the company related information with it. Okay. But most of the times, due to the business complexities or due to business requirements, it will be in the Snowflake schema. If you are working for large organizations, if you are working for a multi-billion-dollar company, usually in my experience, because I worked in all the multi-billion-dollar companies with the sales, all those businesses follows the Snowflake schema. If you are working for small transactions, if you are working in a data mart or small organization, maybe they follow star schema. But sometimes we try to start with the star schema, but somehow due to the complexity we convert into the Snowflake schema. Okay. So this is something on the different examples, right? What we were talking about. Yeah. So we'll continue for next 10-15 minutes and then we'll end up the class. So by that time you should be able to understand what is the dimension table and all those things. Okay. So go through this some of the examples. As I've already told you, go through some of the slides from here, right? So understand what is a dimension table, what is a fact table, right? And what type of data is stored. I'll show you how the data is stored in a dimension table and a fact table. Okay, I'm just going to the AdventureWorks database. I'll go to AdventureWorks DW 2008 R2. Select star from. Okay, I'm just trying to show you some of the database dimension tables and fact tables in this one. Okay, so let me go to the Object Explorer, okay, and see the list of databases I have. Actually, I've restored in a different one. Let me show you something about it here. Okay, so I have a table called AdventureWorks DWX, right? I have a database called AdventureWorks DWX, right? So what I'll do is I'll select star from dim account. So we'll go through some dim product instead of dim account. Dim product, yeah. So if I do a select star from dim product, this will talk only about the product. When you design a dimension table, it should be something like this. This is surrogate key. Product key is nothing but a surrogate key, which is like a primary key. Here you should talk only about the product. Okay. What is the product alternate key? It means it is a maybe item code or model number, right? What kind of product it is? What is the English name of it? What is the Spanish name? What is the French name? What is the color of it? What is the size of it? What is the range of it? Right? it will always talk about a product dimension. So this may be Chinese description, English description, French description, and all those things, right? So it will always talk about product dimension, right? It will never talk about any other things. If it has any other things, it will be null or zero, right? If I take about select star from dim geography, right? So if geography will talk about only about the location, right? So example, if I execute this, so this is a key, this is a city, this is the state, this is the country, this is the continent, and this is the postal code. Like that you have the data for all the cities, all the countries, all the states of the world, right? So this talk only about the location. If I go to the select star from dim employee, if it does a dim employee, it only talks about employee information, right? Employee number, employee name, what is his territory, first name, last name, when did he join, what is his title, what is his email address, what is the phone number, whether he is married or not, what is his male or female, how many number of leaves he has taken, right? So he is talking only about the employee information, right? So these kind of things are called dimensions, right? Dimension means it is talking only about the properties of that particular subject, only about the properties of that particular subject. So what is a fact? Example, we have fact called fact internet sales, right? Fact sales. If you see the fact, example, I have the fact internet sales, right? Example, fact sales quota. Okay, I have a table called fact sales quota. So what I have here, this fact sales quota means this particular table is linked. This is the quota of the different salespersons. Okay, so it means that it should be linked to the employee object, which is the sales rep is present, right? And the quota or target for that salesperson may be different for different year and different month, right? This is linked to the time dimension or date dimension, right? So this is the key and this is the year, right? For this employee, for this year, okay, for this employee, for this year, time key 1 means 2001 and 3, right? This is the sales amount quota. Okay, if I go copy this time key 1, example, if I copy this time key 185, right? If I go back to the date table, what is it present here? 2002 and 1, right? 2002 and 1. So for this key, the same date should be present. Select star from dim. If I go to dim, where is dim date? Okay, we have to call dim time, right? Where time key equal to 185. So this is talking about year 2002 and 3, right? So here you have the, what is the year? Calendar year is 2002. Okay, fiscal year is 2002. Fiscal quarter is 3, right? This year, this quarter. This year, this quarter, right? For this 1 year. So the same key, if I come here for key number 185, this year, this quarter. He's talking about the calendar year. That's why it is 2002 and 1, right? So the same information for this employee, for this key, this is the sales quota. So this is where you can find this key. This key you can find in dim employee, right? Where employee key equal to this one. It means I'll execute this one. So what I'll do is I'll do the same here, just to make you understand. Okay, if I execute these 3 queries, right, at the time, this 268 key is employee is, who is this person? This person is Hung Fu. His name is Hung Fu Ting, right? Maybe a Chinese person, right? And what is this time? This time is nothing but 2012 calendar year and first semester. And this fact sales quota, I applied this key and this time key. So what I am getting for this employee means, for this employee called Hung Fu, for this year time key, it means this is what is this time key? 2002 and first quarter, 2002 first quarter. what is the sales amount? This is a number, right? That's why it is in the fact. It means for this employee, for this time, this is the quota. Like that, for all the employees, for all the times, you will have the quota in this one. For all the employees, for all the time, you will have the quota defined. Yep. So this is something about the dimension tables and fact tables. Okay. Please go through that. And okay, so in the dimension tables, there are different concepts. There are different types of dimensions. Okay. I'll tell you what are the different types of dimensions. I don't want to confuse you in this class without you understanding the concept of dimensions and facts, without you working on the background information of it. I cannot just tell what are the different subtypes in it. You will be lost, right? So this particular section, very important, I will take up in the next class, right, tomorrow. But tomorrow what I want is, I want you to completely read dimension tables, fact tables and all those things, understand the concept of it, okay, and then we'll talk about this, okay. This is about the dimension tables and this is the fact tables, right? And already we have in the initial classes we have gone through the differences between the OLTP system and OLAP system. OLTP means online transactional processing, OLAP is analytical processing. Already I told you about this, right? And you can just go through these slides, why we have to use OLAP and why we use OLTP and all those things, you will understand. But one important topic which I will take tomorrow is dimensional model designs. What are the different types of dimensions we have? Okay, this is very important. But before that, please make sure you study the concepts of dimensions, fact tables. What is a dimension table? What is a fact table? What is a star schema? What is a Snowflake schema? What is Ralph Kimball's approach, or what is Bill Inmon approach? What are the drawbacks of each approaches, and how a data warehouse is built? Okay. So this is what we learned today. So what I'll do is, like, I'll try to see any questions we have. Is there any specific naming convention we need to follow for dimension of fact table and column, or we can say used any? Okay, very good question, right? We cannot follow any naming convention. There is a specific naming convention. Okay, this is given by Microsoft. Any dimension table you are starting with, if it is a dimension table, make it as dim. Dim means dimension table. Dim geography. If I just put the name as geography, I will not know whether it is a dimension table. I will not know whether it is a normal table, right? You should make sure that all the dimension table names are given with dim and all the fact table names are given with fact. This is a very standard practice in any organization, right? If you see something as dim, it means dimension table. If you see something as fact, then it is a fact table. Make sure you follow the same standard, okay? Okay. So I don't think you have any other questions. So I have already answered all the questions. Okay. But any questions, just be frank and try to bring up in the next class, right? So in the next class, just make sure whatever I told you as exercise, just try to complete that. And you have few other sections to do as a pre-work, which we will deal with more on cubes. Okay. Which will deal more on the SSIS cubes. Tomorrow we will work on SSIS and we will use the dimension tables and fact tables and we will build a cube. Okay, so you have to study all these today's concepts and try to study about this pre-work also.